So you tell people you're just like, yeah.
Okay, so let's go ahead and take a look at the answers. Somebody's note. All right, great. So the first one, a blank is the organization of raw data in table form. Frequency distribution, great. It's useful to find the percent of the total that each class represents. This is the relative frequency, good. Blank counts how many data points are in that class or a previous class. Cumulative frequency, great. Blank tells us what percent of the data is in that class or previous class. Cumulative relative frequency, yep, exactly. The blank is how wide the class is. Class width, great. The blank is the value exactly in the middle of the class. Class midpoint, good. Blank, separate the classes. Class boundaries, good. And the smallest and largest possible data values in the class are the lower and upper class limits. Perfect. All right, nice. Okay, good. All right, so then the next page, there are rules for processing group frequency distributions. First rule is there should be 10 to 20 classes. So at least 5 to 20 classes, at least 5 classes. Because if you have 4, then your data is too smudged up, right? Scrunched together, so you want to be able to see a little more definition, a little more information between them. So at least 5 classes, no more than 20, because that's just too frazzled. That's too many pieces. The classes must be mutually exclusive. That means that you can't have something be in 2 classes at once. So in other words, I can't go from like 1 to 10 and 10 to 20 and have 10 be in 2 different classes at once. You can't double count 10. Make sense? The classes must be continuous. No gaps in between. So I can't go from 0 to 5 and then from like 10 to 15 and leave nowhere for like 7 or 8 to be, right? There has to be a place for every data value to go. Classes must be exhaustive. So in other words, I can't have data that goes up to 65 and only have classes that go up to 50 or 60. Right? I have to like go all the way to make sure I include all of my data. If my data goes to 65, I have to go up to 65. And classes must be equal in width. So in other words, I can't have I can't have some that have a class width of 10 and others have a class width of 15, because it's not fair. Right? You have to compare things on equal. Like, if you look at our data here, it's like you can tell like there's a chunk of people who don't drink a lot of coffee at all, and you have to be able to see that, because it should be like the classes should be equal in width, so you can see, oh yeah, it starts off it's really big here, then it's kind of smaller there. There's fewer people who are over this spot. So you have to make sure that all the class widths are the same. So you're comparing apples to apples. Okay. Unless it's open-ended, obviously. That's the one exception. All right. So let's look at constructing a group frequency distribution. Here's my following data. This is your example in your notes. I have, these are the highest recorded temperature for each of the 50 states. You'll notice that we have 103. So actually 103 is your 103 and 134 are the smallest and largest ones. So first, determine classes. We want 7 classes. So how wide is each class? Well, let's take a look at my range. My range here is 134 minus 103. I have 31. Okay, so 31 is more than 25, right? So that means I can go in groups of 5. Why do I want class widths of 5? Because if I have a class width of 5, I can make my data fall on 5s, so it's easier for people to wrap their head around. You guys following what I'm saying?
Yes.
So here, ideally, we want to have class widths of 5. So first, my first step is determine my class width. My class width is 5. Good. So width, so 5. Good. Next step, we need to figure out our 7 classes. So first, take your lowest value. What's my lowest value?
103.
103. Find the 5 that's below 103. If I were to count by 5s, 5, 10, 15, 20, what's the 5 that's below 103? 100. Does that make sense? If you count by 5s, 5, 10, 15, 20, 25, 30, 35, 40, eventually you get to 100. Is everyone following where I'm at with this?
Yeah.
So it starts with 100, because 100 is a good number, we like it. It's a 5, we can wrap our head around it. So that's going to be my first lower class limit. My very first class, the lower limit for my very first class. So 100 is my first lower limit. These are what, temperatures? Temperatures. Okay, so don't worry about what the upper class limit is. Leave it alone. First step is figure out your first lower class limit and then find all the rest of your lower class limits for all the rest of the classes. How do you do that? Add what? 5, the class width. Add the class width. So the next class should start with 105. Does that make sense? So first thing you do is find all the lower class limits first. 105, 110, 115, 120, 125. How many others? 7? So one more. It's 130. Now that we've done this, now we can go back and figure out what came before. So 105, what's number before 105?
104.
104. Perfect. Actually, I think I did this. And then the next one, number before 110? 109. And you know what? That's separated by how much?
5.
5, your class width, right? So just use add 5 if you want. Find all the rest. Done. Good? Has everyone written these in? All right, cool. Now, step 4, find the boundaries if that's required. So, I'm going to help you out with this. So we want to find the number that is between these two guys here. Right, between 104, 105. So 100 to 104, 105 to 109. So the number smack dab between 104 and 105, 104.5. I think I'll do it this way. Right, so 104.5. So really, all you really need to do is you can grab 104 and just add one more decimal place and put a 5 in there, right? And then that's also the lower class limit for the next class. You just write that one in. And then 109, just add a 0.5 on the end of it, right? And then that's also the next class here. So you kind of do it like that, like 129, add a 0.5 on the end of it, right? And that's also the lower limit for the next class. So we kind of follow how that pattern works? Good. Questions about this? And then you should kind of go through it and count out where things go, but I'm going to go ahead and show you guys the tally anyways. So there's the tally. So keep writing the class boundaries if you haven't finished writing them in. And then, I'm going to just give you guys the frequencies now. So those are the frequencies. All right, so you go through, you tally all of them up. Is this still recording? Yeah. Sorry. So for the frequencies, you can just write them down. I'll just give those to you for you guys for those ones, because it's just the example anyways. But then once you find the frequencies, once you write those down, find the cumulative frequencies this time. Figure out the cumulative frequencies.
Cumulative frequencies is like function, right?
It has to be different from that class or previous class. In other words,
No, the cumulative frequency is just, it's like the first one is 2, and then you'd add 8 for the second one, and that would be your cumulative frequency for the second one. So like you just keep adding on.
Adding how much?
Like, so these added together would be this one, these added together would be that one, these added together would be this one. So you just keep going up. Yeah.
All right, so, you guys have, so then once you get this, I want you guys to go and figure out the cumulative frequency. Find the cumulative frequency. So there are cumulative frequencies, anything in that class or previous class.
yeah, so you add the frequency up and then you analyze as it goes. So like 2 plus 8 would be 10 for the second class. So you start on 2, then 10, so on and so forth. 28.
Do you know what I mean?
So I guess you're going to need to, okay, just
All right.
and then it should be sure. So I haven't forgotten it yet.
All right, yellow. Is the way you guys should have your cumulative frequency? Yes?
4, I guess.
Yes.
All right, excellent. All right, so now you guys are going to do a lab problem. Your lab problem is on the next page. Let me point out a couple things about it. One is, here's your lowest number there. I've already told you that I want you to have a class width of 20,000. I've given it to you. You do not have to calculate it. I'm telling you, use a class width of 20,000. So did everybody hear me?
Yes.
What's your class width?
20,000.
Perfect. So take your, here's your lower limit, class limit. You guys can start with that. Remember your first step is to, once you have your class limit and your kind of your lower, you figure out your lower boundary and then find all of your lower boundaries. Find all of your lower boundaries first. Then go back and find your upper boundaries. All right, so go ahead and work on this.